Have you ever wondered what the Earth was like before the dinosaurs? Let's rewind time, all the way back to the very beginning about 4.5 billion years ago. Our planet was a fiery ball of molten rock, spinning wildly in the newly formed solar system. This was a time when Earth was more akin to a flaming hell than the lush green planet we call home today. As the Earth spun, it began to cool down. The outer layer of molten rock started to harden, forming a thin crust. This was the birth of Earth's solid surface, the foundation upon which all life would eventually flourish. This crust was not the stable, familiar landscape we know now. It was thin and brittle, constantly cracking and reforming as the planet continued to cool and solidify. But the Earth was not just rock. Water, the lifeblood of our planet, was also present. It was trapped inside the rocks and minerals that made up the early Earth. As the planet cooled, this water began to escape. It vaporized and rose to the surface, creating a thick, steamy atmosphere. Over time, this steam condensed and fell back to the surface as rain, pooling in the low areas of the crust and forming the first oceans. And let's not forget about the atmosphere. The early Earth's atmosphere was drastically different from what we breathe today. It was predominantly composed of nitrogen along with smaller amounts of carbon dioxide, water vapor, and other gases. There was no oxygen, the element that most life on Earth today relies on. Oxygen would not become a significant part of our atmosphere until much later, thanks to the emergence of life and the process of photosynthesis. So, there you have it. The Earth, 4.5 billion years ago, a newly formed planet with a solid crust, oceans, and a primitive atmosphere. This was the world before life, before plants, before dinosaurs. And yet it was the starting point for everything that was to come. So the stage was set, but it would take billions of years before the first dinosaurs would make their appearance. Now, imagine a world just beginning to breathe life, a world vastly different from the one we know today, a world still forming its identity. Picture an Earth that was still a newborn in cosmic terms, around 3.5 billion years ago. During this time, life began to flicker like a tiny candle in the dark vastness of the universe, in the form of single-celled organisms. These organisms, so small and simple, were the pioneers of life as we know it. They were the first to brave the hostile environment of early Earth, setting the stage for the grand play of life that was to follow. They were the first to perform the most basic yet most vital of life's processes: photosynthesis. Photosynthesis, the process by which these organisms used sunlight to convert water and carbon dioxide into oxygen and glucose, was a pivotal turning point. It was like a breath of fresh air, quite literally, in an oxygen-starved world. This oxygen production wasn't just an afterthought, it was the catalyst that would transform the planet. These single-celled organisms, through their ceaseless photosynthesis, began to fill the atmosphere with oxygen. It was this oxygen that allowed for the development of more complex life forms. Oxygen was the fuel that life needed to evolve, to grow, to diversify. These humble beginnings, these tiny single-celled organisms, were the unsung heroes of life's story. They set the stage, filled the atmosphere with the breath of life, and quietly stepped back as the scene changed and more complex characters entered the stage. Our planet was slowly evolving, but the journey to the age of dinosaurs was far from over. Fast forward to around 540 million years ago, a period known as the Cambrian explosion. This name isn't about a literal fiery blast, but rather a metaphorical explosion, an explosion of life, diversity, and complexity. It was during this period that life on Earth took a dramatic turn. Picture a world where life was mostly simple and microscopic. Suddenly, within a geological blink, the world's oceans filled with a myriad of complex organisms. This was the Cambrian explosion, a period where evolution went into overdrive, and life as we know it began to take shape. The Cambrian explosion was a time of unprecedented evolutionary innovation. For the first time in Earth's history, animals with hard shells emerged. This might not sound like a big deal, but consider this. Before this period, life was soft-bodied and vulnerable. The development of hard shells was a game changer. It offered protection and gave these early creatures a survival edge, allowing them to flourish in environments that were previously inhospitable. But the Cambrian explosion wasn't just about the birth of hard-shelled animals. It was a time of unparalleled biodiversity. Imagine the scene. The ocean floors, once barren and lifeless, now teeming with creatures of all shapes and sizes. From the slow-moving trilobites to the swift and agile anomalocaridids, life in the Cambrian seas was diverse and vibrant. The Cambrian explosion also saw the emergence of the first ancestors of many modern animal groups. So in a way, this period laid the groundwork for the future of life on Earth. It was a time when the blueprint of life was being rewritten, when new possibilities were being explored, and when life was experimenting with forms and functions that would shape the course of evolution for millions of years to come. With this explosion of life, Earth was teeming with diverse creatures, yet the dinosaurs remained millions of years away. As the seas filled with life, the first pioneers began to explore the untouched lands. Life was blossoming under the ocean waves, with a wide variety of fish evolving and diversifying, filling every available niche in the aquatic world. These were not the fish we'd recognize today, but rather unique creatures that were the ancient ancestors of our modern marine life. Among these aquatic pioneers were the jawless fish, primitive creatures that relied on filter feeding to survive. Then came the jawed fish, a significant evolutionary leap that allowed for a more active lifestyle. These jawed fish dominated the seas, paving the way for the first vertebrates. Meanwhile, the first terrestrial explorers were making their debut. The evolution of lungs and legs allowed for the emergence of the first land-dwelling creatures known as tetrapods. These creatures, part fish and part amphibian, were the first to venture onto land, forever changing the course of life on Earth. This brave new world wasn't barren, though. The first plants had already begun to colonize the land, forming the earliest forests. These were not towering trees as we know them, but rather moss-like plants and towering ferns that created a green carpet over the Earth's crust. Along with these plants came the first insects, which played a crucial role in the formation of these early ecosystems. These first forests provided the necessary oxygen and food for the tetrapods, and the insects offered additional sources of nutrition. The interplay between these different life forms created a complex web of life on land, mirroring the diversity found in the seas. As the tetrapods continued to evolve, they gave rise to the first true amphibians, and later, the first reptiles. Each step brought life closer to the forms we recognize today, setting the stage for a new era of terrestrial dominance. The land was ready, and the stage was set for the next chapter in Earth's history. This was the age of fish and the first land walkers, a fascinating time of exploration and adaptation that laid the groundwork for the future of life on Earth. Before the dinosaurs, another group of creatures ruled the Earth. Let's take a step back in time to a period known as the late Permian and early Triassic, some 250 million years ago. This was a time when the Earth was dominated by a group of reptiles known as the archosaurs. These creatures weren't your typical run-of-the-mill reptiles. They were the real deal, the apex predators of their time, ruling over the Earth with scales and sharp teeth. The archosaurs were a diverse group, ranging from crocodile-like creatures to large bird-like reptiles. These creatures had some key features that set them apart from other reptiles of their time, including a unique arrangement of holes in their skulls and a distinctive ankle joint. They were also among the first reptiles to evolve a fully upright stance, with their legs positioned directly beneath their bodies, a feature that would later become a hallmark of the dinosaurs. But as with all things in life, the reign of the archosaurs couldn't last forever. Around 200 million years ago, a series of cataclysmic events unfolded that would change the course of life on Earth. Massive volcanic eruptions filled the atmosphere with ash and toxic gases, blocking out the sun and causing a dramatic drop in global temperatures. This was a time of great upheaval and extinction, and many of the archosaurs didn't survive. But as the saying goes, when one door closes, another opens. The extinction of the archosaurs cleared the way for a new group of creatures to take center stage. From the ashes of this devastation, the dinosaurs emerged. They inherited a world that was drastically different from the one their predecessors had known, a world that was ripe for their conquest. And so, after billions of years of evolution and countless transformations, our Earth was finally ready for the age of the dinosaurs.